we have seen right yesterday. So this is an inverter. Okay. So ఇదే కదా నిన్న చూసింది CMOS NAND gate. I told you to write the code for this CMOS NAND gate. So normally if you see A is supply and supply 0 is there. A is supply 1, supply 0 is C. Okay, you can see here C. So we have two PMOS transistors and two NMOS transistors. So if you see the connections here, you are instantiating PMOS transistors to PMOS transistors. So for the first PMOS transistor, it work normally. Output is out, inputs are input 1 and input 2. Supply 1 you are naming it as A, supply 0 you are naming it as C. Okay, wire B. Okay, in wire B, we'll see what is this wire B. You can see here for PMOS, first PMOS P2 undi kada, P2 QP2 transistor. What are the inputs and outputs? Inputs are into and A. Output is inputs are yes, A and into are the inputs. Okay, what is the output for this QP2? For PMOS 1 చూడండి ఇక్కడ. So A for PMOS 1, inputs are in 1, okay, B and out is the inputs. For PMOS QP1 transistor is there, right? For this output is sorry, then B is the output and QP1 transistor inputs are B, in 1 B are the inputs or out is the output. Okay, so in 1 B and out is the output. Okay, for NMOS also, if you can see what are the inputs and outputs for NMOS 1, so out is the output, in 1 and sub C are the inputs. Okay, similarly output out C are the inputs and sorry, out is the output, C and into are the inputs. Simple to design this NMOS. Okay. Now with pull-up load, okay, we are using a pull-up load. Pull-up load ante main cheppanu ikkada, when you are connecting the gate and source, okay, gate and source of the MOSFET, then it will be acting like a pull-up device. Okay, it will be acting like a pull-up device. Now you can see the operation. Q1 is the NMOS transistor. Q2 is properly biased from an active resistance. Okay, when input is equal to 0, yes, when input is equal to 0, Q1 is off. When input is equal to Q1 is off, what will be your output? Output will be equal to VCC. When input, what is your output? Output will be equal to VCC. When input is equal to 1, when input is equal to 1 second, wait. Okay, when input here it is equal to 0, the out for an NMOS, this transistor will be off. When this transistor is off, when input is equal to 0, what will be our output? Output will be equal to VCC. Okay, output will be equal to VCC. When input is equal to 1, this transistor will be on, your output is nothing but it is supply 0. Okay, so this is your NMOS inverter with pull-up load. So you can see the operation I have explained you. Pull-up load ni meer instantiate cheyali ante ela ante simply you need to use pull-up. Okay, so pull-up is the keyword for this pull-up resistor. This is pull-up device and out is the pull-up device. NMOS as usual. Okay. Test bench you can give any thing. Okay. Instantiate మీరు ముందు రాసినట్టే టెస్ట్ బెంచ్ రాయొచ్చు. ఈ సర్క్యూట్స్ ఏవి కూడా సింథసైజ్ అవ్వవు, ఎందుకంటే మనం స్విచ్ లెవెల్లో చేస్తున్నాం కాబట్టి దే ఆర్ నాట్ సింథసైజబుల్ సర్క్యూట్. సో దిస్ ఇస్ 3 input నాట్ గేట్, 3 input నాట్ గేట్. దీన్ని ఎలా ఇన్స్టాన్షియేట్ చేస్తా చెప్పండి. NMOS Q4 MOSFET ki what are the inputs and outputs for 3 input NOT gate. So what is this? This is pull up and this is pull up, right? Okay, Q4 is pull up. Pull up ki output is B. Okay, Q1, Q2, Q3 is there, right? It is NMOS. Okay, Q1 ki what are the outputs and inputs? So B is the output. Okay, in 1 supply 0 are the supply 0 are the inputs. Okay, Q2 ki, so B is the output into supply 0. Okay, Q3, what is this? B is the output in 3. Simple way you can write. In 1 into in 3. Okay, output is B. Output is P for everyone. So supply is determined. Supply ni manam enti, supply is nothing but it is mentioned as A. Supply 0 ki the name of the supply 0 is simulation results. And the same module you can design like this. Okay. Converter with active pull down. Pull down ki PMOS instantiate cheskondi. Pull down ki what you will write. Okay. PMOS aithe module, all those things you write. PMOS ki what are the outputs? Out is the output, in is the input, and one more input is VCC is one more input. Okay. Next you are using pull up, pull down. What is this pull down device? Out is the output. You are using a pull down circuit. Here no more inputs. Okay. So out is the output for pull down. Pull down lo ee rendu short ayi untayi kabatti. Next we will see CMOS switch. CMOS switch, the operation of the CMOS switch. So you have P control and N control. So when P is equal to N, when P is equal to 0, N is equal to 1, out is equal to input. Okay. Okay. So N control on ante NMOS transistor keeps it on when it is in the state 1. P control turns on when PMOS. So దీన్ని సింపుల్ గా ఇక్కడ చెప్తాను చూడండి. P is equal to 0, P control. N control is equal to 1 అయితే out is equal to in. Okay. Similarly, P is equal to 1, N is equal to 0 అయితే out is equal to Z అంతే. Okay. So ఈ రెండు మీరు కరెక్ట్ గా ఇస్తేనే it will act like a short circuit. Okay. When P is equal to 0, N is equal to 1. So out is equal to, లేకపోతే it will act like open switch, out is equal to Z. Okay. How to instantiate CMOS switch? CMOS, you give any name here. Out, in, and control, P control. Okay. So CMOS is a keyword for switch instantiation. TSW is the name assigned to the switch in the instantiation, and out is the name assigned to the output variable in the instantiation. In is the name assigned to the input variable in the instantiation. N control is the name assigned to control variable as a NMOS transistor in the instantiation. And P control is the name assigned to control variable. Okay. This is your CMOS switch. Simply you can CMOS switch how to write the model, how to model this CMOS switch. You can see output is out, input is idi kada. This is your CMOS switch. P, this is P control, N control, and inputs and outputs in and out here. This is your out. So what are the inputs and outputs? Output, input. So N control and P control. Output is out, input is in. These control signals are also, these are the inputs. Okay. So NMOS key, what is the output? Out in control, N control. PMOS key, out in P control. End mode. Test bench. This is switch 2. How do you program the switch 2? It is having an inverter as well as one CMOS switch. Okay. Simply దీన్ని ఏం లేదు, ఇక్కడ ఏం చేశారు అని అంటే పీ కంట్రోల్ ఎన్ కంట్రోల్ సపరేట్గా ఇవ్వకుండా జస్ట్ ఒకటే లైన్ ఇచ్చారు. సో కంట్రోల్ ఇఫ్ ఎన్ ఈజ్ ఈక్వల్ టు 0, ఆబ్వియస్లీ ఇక్కడ ఇన్వర్టర్ పెట్టారు. పీ ఈజ్ ఈక్వల్ టు 1. ఇఫ్ ఎన్ ఈజ్ ఈక్వల్ టు 1, పీ ఈజ్ ఈక్వల్ టు 0. This is the module. You are using one NOT gate here. So the output is P control, input is control for this NOT gate. Okay. CMOS as you out in the control and control, P control and N control. So this is a simple RAM cell. Okay. So this RAM cell, it is having 2 switches, 2 gates, and 3 switches and 2 gates. Okay. So ఇక్కడ మధ్యలో ఉన్నది ఏంటి చెప్తారా? బ్యాక్ టు బ్యాక్ కనెక్ట్ అయిన ఇన్వర్టర్స్. ఇదేంటి, ఇది చూస్తే ఏం గుర్తుకు రావట్లేదు. So this is indicating a latch. Okay, feedback latch. And this is indicating a latch. You can see when switch 2 is on, QB, the output of the inverter G1 forms. Let us start analyze. Let us analyze this circuit. Program easier if you have the circuit. Okay. So when switch 1 is on, what is happening? Let me కనిపిస్తుంది కదా. No. So here when switch 2 is on, okay, when switch on undanukondi, when switch, okay, when the switch 2 is on, so the output of QB is the output, right? Okay, the output of inverter G1, okay, the output of inverter G1 forms input to G2. Okay, so is switch on unte, just this the data is latched here. Okay, the data is stored in between these 2 inverters. Okay, so similarly you can see when WS bar is equal to high, ఇది ఇంకా కొంచెం పెద్దగా చేయొచ్చు. Good idea. Now you can see this. When WSP, this is high, this is high, that when WSP is equal to 1, a write or store. Okay, WSP is write or store. When this is high, what happens? Which one will be on and tick pedte on. And switch to, when the switch is on, the WSB, this switch 2 will be off. Okay, it will be open circuited. Okay, ఇక్కడ బబుల్ ఇచ్చాం కాబట్టి 1 ఇచ్చినప్పుడు here 0, the switch 2 will be off. Okay, so with when switch 1 is on, whatever the input data is there, right, input data is connected to gate G1. Okay, input data is directly connected to G1. Okay, input data is directly connected to G1 when the switch 1 is on. Okay, so it will be connected like this. అంటే మీకు వచ్చే సర్క్యూట్ ఎలా ఉంటుందంటే, సో స్విచ్ 1 ఆన్ ఉన్నప్పుడు యువర్ సర్క్యూట్ విల్ బి లైక్ దిస్. ఓకే, సో ఇది స్విచ్ 2 కదా, స్విచ్ 2 ఇట్ విల్ బి లైక్ ఓపెన్ సర్క్యూటెడ్. ఓకే, ఇట్ విల్ బి లైక్ ఓపెన్ సర్క్యూటెడ్. ఇక్కడ ఇస్తున్నారు కదా ఇంకొకటి. Okay, this is like open circuited. So data అనేది directly it will this latch will be taking the data, but this latch it is not getting stored. Okay, so we can write the data, whatever the data is there, we can force the data into the latch. Okay, so the circuit will be like this. Okay, circuit will be like this. Whenever WSB goes low, the WSB is equal to 1, switch 1 is on. Whenever WSB goes low, ఇప్పుడు ఈ కండిషన్ లో చూద్దాము. So whenever this WSB is going low, what is happening? Switch 2 is, this is on, and this transistor switch 1 is off. Okay, switch 1 is off. అప్పుడు వచ్చే సర్క్యూట్ ఏంటిదనంటే it will be like ఇలా ఉంటుంది. Okay, when WSB is equal to 0. Okay, when WSB is equal to 0. Okay, so అంటే ఏమవుతుంది, when if you want to write the data, switch 1 on ఉన్నప్పుడు you are writing the data. Okay, you are writing the data. Actual గా ఇలా ఉంటుంది చెప్పాలంటే సర్క్యూట్. When switch 1 is on, you are writing the data. When switch 2 is on, whatever the data that is being latched అంటే స్టోర్ అవుతుంది అన్నమాట. Okay, so WSB1 data is transferred, WSB0 what is that, data is latched. Okay, then we can say data is stored in RAM cell. When read goes active, read goes active, which is equal to ఇది 1 ఉన్నప్పుడు RD is equal to 1, whatever the latched data is there, right, ఇప్పుడు RD is equal to 1 కి whatever the latched data is available at the output. Okay, so whatever the data is there, the latch అయిన data ఉంది కదా, so this latched data is switch 3 on ఉంది కాబట్టి RD is equal to 1, switch 3 is on. Okay, when this switch 3 is on, what happens, D0, you can, whatever the data is there, you can read out here. Okay, so this is the operation of RAM cell. Okay, so simple thing, WSB ఇది 0, ఇది WSB 1 ఉన్నప్పుడు what happens, data will be stored, data is transferred. Okay, WSB 0 ఉన్నప్పుడు data is stored. Okay, so RD is equal to 1 అయితే stored data you can read. Okay, this is the operation of exam. ఇదే మీరు డిజైన్ చేయాలి అని అంటే you can see here, simple thing. Okay, so this is RAM cell, input is DIN. Okay, wire is SB, wire QQ. Q and QQ are the wires. మళ్ళీ కట్ చేసి You can see here, just నేను names కోసం పెడుతున్నాను figure ని పక్కన. Okay. We have చూడండి, RAM cell input is, output is D0, input is DN. Okay, DN, WSB, RD, and wire is SB. Okay, ఇక్కడ what is that SB ఎక్కడ ఉంది? RD is the output. Yeah, SB అనే ఒక వైర్ తీసుకుంటున్నాం. ఇంకోటి QQ, and try is D0 is try. Okay, ఇది QB అన్న, SB కాదు. లేకపోతే ఇక్కడ SB అని పెట్టచ్చు. QB SB ఇచ్చారు. ఫిగర్ లో QB అని ఇచ్చారు కదా. ఓకే, లెట్ QB SB వాట్ ఎవర్ ఇట్ మే బి, ఏదో ఒకటి పెట్టుకోండి. సో QB ఇస్ ద వైర్. ఓకే, QB ఇస్ ద వైర్. సో స్విచ్ 1 చూడండి, స్విచ్ 1 కి ఇన్పుట్స్ అండ్ అవుట్పుట్స్ ఏంటి? కాదు, దట్ ఈస్ ఇన్పుట్ మా వైర్ ఆఫ్. లెట్స్ సి, USB RT. ఓకే, లెట్స్ సి, ఇది దీంతో అర్థమవుతుంది. సో స్విచ్ 1 కి అవుట్పుట్ ఇస్ Q, DN and WSB are the inputs. Okay, so DN and WSB are the inputs, Q is the output. Okay, so here switch 2 ki chudandi, switch 2 aithe QQ is the Q is the output. Okay, Q is the output. Okay, tarvata what is this? QQ is the one input and SB ante yes. Okay, WSB the bubbled kada, so here SB you are taking. Yes, switch 3 ki D0 is the output, Q D0 is the output, RD is one input, and it got into the QQ వస్తుంది. Here you have QQ. Okay, so you have taken NOT gate 1. So ఇక్కడ ఉంది కదా NOT gate 1 కి, so SB is the output, WSB is the input. NOT gate 2 కి but the NOT gate 2 QB is the output. Okay, QQ is the input, Q is the input, or QQ is the input. So N3 NOT 3. So what are you doing? QQ is the output and Q bar is the input. Okay, this is one NOT gate, this is one NOT gate, and here also you need to take a NOT gate. N module. That's it. Okay. ఇక్కడ ఏంటంటే చూడండి, RAM cell లో you have instantiated CMOS కదా. Instantiated CMOS. Okay, so CMOS which you have instantiated kabatti, what you have to do is you need to write the code for CMOS switch also. Okay, that's it. Inkoti, this is alternate version of the RAM cell. You can just try it. I'll be sharing you. This is a shift register, dynamic shift register. Okay, dynamic shift register lo how many we need to instantiate 4 CMOS switches, 1 2 3 4. Inkoti CMOS switches 4 and normal CMOS inverters you have to instantiate like this. So you can see 3 successive stages of dynamic shift register. Ante it is a 2-phase clock system. Clock is 5-1 and 5-2. Okay, 5-1 and ikkada 5-2 5-1 5-2 5-1. Okay, 2-phase clock system. Alternate ga what shifting is done in alternate clock cycles. Okay, successive stages are given input to CMOS switches. So here when phi 2 is on and phi 1 is off, what happens? D is an input to stage 1 to ఇక్కడ చూద్దాము. So what happens? VCC and here we have D in అనేది shift register అంటే whatever the data which we are giving 0011 ఇచ్చారు. Okay, shift register should shift the data. Okay, so when ఇక్కడ కండిషన్స్ ఏంటిదంటే చూడండి, ఫస్ట్ కండిషన్ phi 2 is on and phi 1 is off. Okay, phi 2 is on. Okay, phi 1 on ఉంది. Okay, phi 1 on ఉంటే what happens? This switch will be on and this switch 3 will be on. Okay, switch 3 will be on. And here also state of stage 2 is coupled to the input stage 3 through switch SW2, and stage 3 it will take the new state. In the next half cycle phi 1 is on. First half cycle lo entidi phi 1 Q2 on, Q1 is on. Okay, so Q2 on and Q1 into phi 1 phi 2 కదా. Q2 on, sorry, phi 1 phi 2 off and phi 1 is off. Okay, let me check once. Here see, when phi 2 phi 2 is on, okay, phi 1 is off. Okay, phi 1 is off. So here Din is the input to stage 1. ఎక్కడికి వెళ్తుంది? Din is the input to stage 1. Okay, so ఇక్కడ D3 D2 D1 D0 D is equal to, so Din is the input to stage 1. ఇక్కడ this is stage 1. ఒక స్విచ్, ఒక ఇన్వర్టర్, it is indicating stage 1. Okay, stage 1 through switch 1. Okay, నేను switch 1 2 3 4 అన్న, switch 0 అని రాస్తాను. Through this switch 0. Okay, ఇది 0, ఇది 1, ఇది 2, ఇది 3. Okay, switch through switch here switch 1 as well as switch 3 will be off. Okay, ఇది off లో ఉంటుంది, ఇది switch 3 also will be off. Okay, switch when switch 2 and switch 1 and switch 3 are off and switch 2 will be on. Switch 2 will be on. So here state of this stage 2, the state of the stage 2 is coupled as input to stage 3. Okay, its state of the stage 2 is coupled as an input to stage 3 through switch S2, right? Okay, it is through this switch SW2. Okay, and here now switch 3 will takes the new state. Okay, and again during the next half of the cycle what happens is, ఇది first cycle లో. Okay, next half cycle లో what happens is phi 1 is on. Okay, phi 1 is on, phi 2 is off. Okay, phi 2 is off, and here switch 0 switch 1 is on, switch 3 is on, switch 2 and switch 0 are off. Okay, so here stage 1 state is, this is stage 1, idantha kalpi stage 1. State of stage 1 is coupled at the input to stage 2, right? Input to stage 2 ఈ switch 1 తోటి రెండు couple అయి ఉన్నాయి, and through switch SW1, and it takes new state from stage 3. Okay, and it takes up the new stage from stage 3 through switch SW3. Okay, so this is dynamic shift register. Here the data in the input line are latched and shifted on the next consecutive. Whatever the data is there, the data is the input line are latched అంటే ఒక చూడండి ఇది. Okay, so phi 1 ఒక clock, 5 2 ఇంకొక క్లాక్ ఇచ్చాను అనుకోండి. సో ఈ 5 1 ఒకటి 5 2 ఒకటి ఇచ్చాను. ఓకే, సో డ్యూరింగ్ this is the data input. So first it is latched once and it is shifted in the ఒక క్లాక్ సైకిల్ లో డేటా latch అవుతే ఇంకొక క్లాక్ సైకిల్ లో the data is shifted. Okay, the data is shifted. So the data is in the input line are latched and shifted on the successive clock cycles. Okay, so all these three stages together is called as shift register. Okay, it is called as shift register. Okay, so here the two-phase clock which we are using, it is defined, it will define the, it is defined as function. Okay, so shift register, this shift register we can modify. Okay, dynamic logic by the dynamic logic using NAND and NOR gates, incorporating NAND and NOR gates we can modify. Okay, so ఇంకా రకరకాలుగా యూజ్ చేయొచ్చు దాన్ని షిఫ్ట్ రిజిస్టర్ని. సో generally this is switch level modeling for shift register. You can even try this program, it is very easy only. అన్ని కూడా క్వెస్టాసిమ్ లో సింథసైజ్ అవ్వవు, సిమ్యులేట్ అవుతాయి. క్వెస్టాసిమ్ కానీ నేను ఇంకా అదేమంటారు స్పైస్ ఉంటే స్పైస్ అడగండి సార్ని ఒకసారి, హెచ్ స్పైస్ లో సిమ్యులేషన్ చేసుకోవచ్చు. సో నేను ఇంకో చిన్న సాఫ్ట్వేర్ మీకు జైలింగ్స్ లో డైరెక్ట్ గా రావు ఇది స్విచ్ లెవెల్లో. నేను ఇంకొక చిన్న సాఫ్ట్వేర్ డౌన్లోడ్ చేసి మీకు ఇస్తాను కావాలంటే. Tomorrow switch level modeling also will be over. ఇంకా పెండింగ్ ఏమున్నాయి చెప్పండి. నేను మాడ్యులర్ ఎన్కౌంటర్ ఒకటి వి విల్ డిజైన్, మాడ్యులర్ ఎన్కౌంటర్ ఒకటి లేదంటే ఒక సీక్వెన్స్ డిటెక్టర్, ఒక మాడ్యులర్ ఎన్కౌంటర్ we will be designing and together we will be writing the Verilog code. మీరు దానికి కోడ్ రాయాలి, Verilog code. నేను హింట్ ఇస్తాను మీకు, ఈ రెండు చెప్తాను. తర్వాత థియరీ కాన్సెప్ట్స్ ఉన్నాయి. వీలైతే టుమారో ఇస్ సాటర్డే రైట్, మండే వరకు ఐ విల్ ట్రై టు ఫినిష్ ఆఫ్, కొంచెం ఎక్స్ట్రా టైం అయినా సరే కానీ మండే ఆర్ బై ట్యూస్డే. ఓకే, విల్ ఫినిష్ ఆఫ్ దిస్ కంప్లీట్ Verilog. So that's it. Anything else? స్విచ్ లెవెల్ మోడలింగ్ మాత్రం మీరు ఈ ప్రోగ్రామ్స్ అన్ని కూడా క్వెస్టాసిమ్ లో చేయండి, సిమ్యులేట్ చేయండి. జైలింగ్స్ లో ఎగ్జిక్యూట్ అవ్వవు, ఈ సింథసైజ్ అవ్వవు ఇవన్నీ కూడా. ఎనీథింగ్ ఎల్స్ ఆర్ షెల్ ఐ సైన్ ఆఫ్? See you tomorrow.